The aim of this lesson: how does a lever work? The learning goals: by the end of this lesson, I hope that you're able to identify the parts of a lever. And if you want to take it a step further, I want you to think about how you can take a lever and turn it into an experiment using the scientific method. A lever is a type of simple machine. If you remember, a simple machine is a tool with few or no moving parts that makes work easier. Some other simple machines are the wheel and axle, a screw, an inclined plane, a wedge, and a pulley. A lever is a board or rod that is free to pivot at a certain point. Levers help lift weight with little effort. Some examples of levers that you might have seen or used are a seesaw, a crowbar, a hammer, a pair of scissors, pliers, and bottle openers. Now we're going to take a look at how the lever works. We're going to start with looking at the basic parts: the fulcrum, the load, and the effort. The fulcrum is the pivot point. The load is the weight that is moved, and the effort is the force that is applied to move the load. And just adding on to the different parts, we have what's called the load arm and the effort arm. The load arm is the distance between the load and the fulcrum. The effort arm is the distance between the effort and the fulcrum. By moving the fulcrum, we can change the length of the load arm and the effort arm. We can increase the load arm by moving the fulcrum closer to the effort, and we can increase the effort arm by moving the fulcrum closer to the load. Moving the fulcrum can make it easier or harder to lift the load. In this diagram, you have effort being applied to the right side, as indicated by the down arrow, to lift the blue box on the left side, which is our load. In a real life example, here's Steve. Steve was replacing my porch, and he had trouble lifting up the wood. So he pulled out a crowbar. The crowbar he placed underneath the piece of wood that he's trying to lift. That's our load. And using his arms, he applied effort to the other end to lift the board out of place. Here's a simple lever that I made using a ruler, some bathroom cups, and the pencil. So the pencil is going to be the fulcrum, and if you remember, that's the point at which the board, or in this case the ruler, will rest. This is our load. This is going to be what we try to lift, and this is the effort. This is where we're going to apply the force. I'm going to use this large shooter marble. This will be our load, and in order to move this heavy load, I'm going to use some smaller marbles. So we just want to lift it. So we're applying the force or effort. And if you're noticing, we're actually getting a little bit of a lift off here. So the more marbles that we're adding on, the more effort we're applying, the more we're able to lift our load. So earlier we talked about the load arm and we talked about the effort arm. If we move our fulcrum closer to the load, we have a longer effort arm. If we move the fulcrum closer to the effort, we have a longer load arm. Well, that's all for today's lesson. I hope you understand a little bit more about how levers work. And again, I want you to think about how to take the system you saw, change the parts around in order to make an experiment about levers. Before you go, don't forget to write at least 3 questions on the left side of your notes, and then write at least 2 to 3 sentences at the bottom summarizing what the lesson was about. If you can, try to answer the aim in the summary section. I'll see you next class. Bye-bye.